I know my picture doesn't tell the story completely. Let me just talk. So in the backyard, I got a pool that has a 100-gallon capacity and it's full of water. Now initially the water's clean, but my cat Pythagoras has hooked up 2 hoses to my pool, pumping in water or fluid at a rate of 2 gallons and 3 gallons per minute. Now, with the rate of flow of fluid at 2 gallons per minute, that's coming through a hose that contains clean water. But in the hose containing or bringing in 3 gallons per minute, it contains a concentration of 1/10 of a gram per gallon of liquid catnip. Now, the pool is full, so as all this water is coming in, it's overflowing. And it's overflowing at a rate of 5 gallons per minute. My question is this: how much catnip in terms of grams, measured in grams, is in my pool at time t? So to figure this out, I'm just going to note that the rate at which the amount of salt in my tank, I said salt, the rate at which the amount of catnip in my tank is changing with respect to time t can be interpreted as nothing more than the rate at which that liquid catnip is coming in minus the rate at which it's going out. I'm just trying to build a differential equation out of thin air. Slipping down a little because I'm running out of room, looks to me like dA dt can be expressed in more detail as follows. Now I'm talking about the rate at which the catnip's coming in. So take a peek at this rate of flow of fluid. And if you don't mind, I'm going to include my units initially, just my first line, just in case I make a mistake, and then I'll just erase my units. So the rate at which the water is coming in is this. But that doesn't answer the question. I'm looking for the rate at which the catnip's coming in. So I'm going to multiply the rate of flow of water coming in from that hose by the concentration of catnip in that water coming into the second hose. Would that be 1 gram per? Is that going to be actually 10 gallons? Now I kind of like this because notice my gallons are canceling, and the final units are going to be grams per minute, which they should be in terms of describing the rate at which the liquid catnip's coming into the tank at time t. So let me talk about my next term over here, minus the rate out. Well, the rate out likewise is going to be 5 gallons per minute in terms of rate of flow of fluid. But that's rate of flow of fluid or water. It's not the catnip. So I need to multiply this by the concentration of catnip in the tank at time t. But I'm going to make an assumption. I'm going to assume there's some grand mathematical god with a huge spoon mixing my water well so that the concentration of liquid catnip at any point in this body of water is the same. But at time t, the concentration of catnip in this pool at any given point, therefore, will be the same as the concentration of liquid catnip in this outflowing water hose. And the concentration of catnip at time t in that tank is nothing more than a ratio of the amount of catnip, which is unknown, to the amount of fluid at time t. Well, as time goes by, I have 5 gallons per minute coming in, 5 gallons per minute going out. The amount of water is not changing. It's a tank that contains 100 gallons of water, so there is my amount of water, measured in gallons. Now here too, just double checking things real quick. A is the amount of catnip, which is measured in grams. My gallons are changing, and thank goodness my units are making sense. So if you don't mind me cleaning up this differential equation, does that look like this? Now that certainly is a separable differential equation, and so technically speaking, you and I can solve that differential equation. I'm here today just merely to set things up. Now I admit, I don't like this example. It's not very complex, so if you don't mind, I may take a short break and come back to this and just spice it up a little bit.